Hello, how are you? Myself Virendra Kumar and you are watching Hero Cosmos and you all are welcome. In this video lecture, we are going to solve a numerical problem related to physics that is asked in IIT JEE Mains examination 2021. So the question read as a person standing on a spring balance inside a stationary lift measures 60 kg. The weight of that person if the lift descends with a uniform downward acceleration of 1.8 meter per second square will be how much Newton? Given is g is equal to 10 meter per second square. So इस प्रॉब्लम में हमें उस पर्सन का जो है वेट अपरेंट वेट निकालना है जब लिफ्ट जो है डाउनवर्ड यूनिफॉर्म मोशन में हो। तो चलिए सॉल्व करते हैं प्रॉब्लम को। सो सपोज दिस इज ए लिफ्ट एंड a spring balance is kept inside this lift. So some spring balance is kept inside this lift. This is lift and a person is standing on this lift and he enjoying the rest position. Initially he was in rest. So when he was in rest, so the mass of that person is 60 kg. Mass of person is equal to 60 kg in rest, right? So you can imagine here that when the lift is stationary, then the only force acting on this system is the gravitational force, that is downward. Gravitational force that is downward, and that is mg, and there is an equal opposite normal reaction, and that is measured by the spring, and this is the normal reaction, and this is n, and that measures 60 into 10, right, equal and opposite. So n, when it is in the rest, lift is in rest, then these two forces balance each other and the system is in equilibrium position. Now as the lift starts descending with downward acceleration 1.8 meter per second square. So second case is that lift starts moving in a downward direction, and that is with the downward acceleration a is equal to 1.8 meter per second square, right? So when we are outside of this lift, we see that lift is moving downward, but and that lift will be the non-inertial frame of reference. But inside this lift, when you are inside and measuring the motion, for that time you are in the inertial frame of reference, and you will experience, that person will experience the pseudo force acting upwards. So when it is in the downward motion, so there will be the net force, and that is the acceleration into mass, and that is given by, and then there will be the different normal reaction other than the initial normal reaction. Suppose in that time this normal reaction is n prime, right? So in that time, so mg is acting downward, and then that normal reaction will be n prime, and that is you have to measure. That normal reaction will ultimately give the apparent weight of the person when the lift is going downward, right? So this is the equation of motion by the Newton's second law. So m is equal to 60 kg and a is equal to 1.8 meter per second square is equal to 60 kg into 10 minus n prime. So n prime is equal to 600 minus 60 into 1.8. So 600 minus 108. So we get, so here 2 and 9, 492, right? So this is the 492 Newton apparent weight of the person. So here I think you got the solution. So I repeat the solution. आप जब लिफ्ट जो है रेस्ट में है तब सब कुछ नॉर्मल है, और जो जो पर्सन का वेट है वो स्प्रिंग जो है नॉर्मल रिएक्शन के रूप में दे रहा है, और वो जो वेट है वो हमारा डाउनवर्ड जो एम जी है उससे हमारा ये बैलेंस हो रहा है इसका रिएक्शन। तो रिएक्शन इक्वल टू एन इक्वल टू एम जी हो गया, ठीक है। बट जैसे ही लिफ्ट डाउनवर्ड मोशन में आती है तो इसके अंदर एक्सीलरेशन होता है, उसकी वजह से इस पर्सन पर जो अंदर है उस पर सूडो फोर्स लगता है, ठीक है, क्योंकि हमारा लिफ्ट एक्सीलरेटेड है उसकी वजह से उसके अंदर जो है सूडो एक्सीलरेशन लगेगा और सूडो फोर्स जनरेट होगा। तो सूडो फोर्स और हमारा अब जो है जब जब एक्सीलरेशन में होगा तब हमारा नॉर्मल रिएक्शन चेंज हो जाएगा, ठीक है। तो नॉर्मल रिएक्शन चेंज होने का मतलब ये हमारा उसका वेट चेंज होगा, दैट इज अपरेंट वेट हम निकालेंगे। अपरेंट वेट जो है हमारा जो है न्यूटन सेकेंड लॉ ऑफ मोशन से हो जाएगा, ठीक है। तो दिस इज द सॉल्यूशन फॉर द अपरेंट वेट ऑफ द पर्सन।